Okay, Bismillahirrahmanirrahim. Let's start today's lecture. By the way, what is the name of the chapter going on?
Hydraulic jump.
Very good. Hydraulic jump. And you know, in this chapter, we already have solved 2 numerical problems. Today, we want to solve the third one. So, what is the problem statement? In a rectangular channel, which is 1.5 meter wide, the observed conjugate depths are 20 and 90 centimeter. Means y1 and y2, these are given. Determine rate of flow and loss of hose power. So we have to determine the capital Q. And if you remember, we discussed one purpose of the hydraulic jump, that it's a crude discharge measuring device. So a hydraulic jump can be used to measure discharge. And now we are solving that problem. How a hydraulic jump can be used to measure the capital Q. He is saying that also compute loss of horsepower. So we have also to compute delta P. So how we can solve it? This problem, when the y1 and y2 conjugate depths are known, so we can compute small q by using equation of hydraulic jump for rectangular channels. So now please write first of all applying equation of hydraulic jump for rectangular channels. What is that equation? Small q square over g, that is equal to product of conjugate depths into average of conjugate depths. So means y1 into y2 in brackets y1 plus y2 over 2. Is this equation?
Yes, sir.
Okay, please now put the values. So the q square over g, what should be the value of the g? 9.81. And then y1 is 0.2 meter, y2 is 0.9 meter, then in brackets 0.2 plus 0.9 over 2. And now you should be able to compute small q. Can you give me the value of small q?
0.985.
Yes, very good. 0.985 cubic meters per second per meter. Now how the capital Q can be obtained?
By multiplying it with width.
By multiplying width of the channel.
Yeah, very good. So capital Q is equal to small q into B, and B is given 1.5 meter. So now compute capital Q. How much you are getting capital Q?
1.47.
Yes, 1.47 cubic meter per second. And just put it in a rectangle and write answer. This is the first answer. Now what else we have to compute? Delta P. So delta P is equal to gamma Q into delta E. And what is delta E? E1 minus E2. And to compute E1, E1 is Y1 plus V1 square over 2G. Do we need V1 and V2?
Yes, sir.
Yes. So first now compute V1. V1 should be equal to Q divided by Y1. And V2 should be equal to small q divided by Y2. And we have values. So please give me value of V1 and V2. What are values of V1 and V2?
4.925.
Yes, very good. 4.925 meter per second is V1. And how much is V2?
1.09.
Very good. 1.09 meter per second. Now what is equal to delta E? E1 minus E2. And put the value of E1, Y1 plus V1 square over 2G, then minus brackets Y2 plus V2 square over 2G, and then put values and give me value of delta E. How much is delta E?
Zero 0.475.
Delta E 0.475 meters. Very good. Now we have to compute delta P. This is equal to gamma Q delta E. What is the value of gamma for water?
1980.
9810 newtons per cubic meter.
Six eight five zero watts.
Yes, good. 6850 watts. But he is saying that compute this loss of horsepower. It means in which units he is desirous to get the loss of power? In horsepower.
Horsepower.
So we have watts. So divided by 746 would be horsepower. So what is the
9.18.
9.18
18.
horsepower? So this is the answer. By the way, what is 1 horsepower? How we can define 1 horsepower?
It's equal to 746
Yeah,
watt.
that is the equivalence. But how we can define 1
Okay.
watt or 1 horsepower? One horsepower, it is the rate of performing of 550 foot-pounds of work in 1 second.
Second.
All right. And what is 1 watt? Rate of performing of 1 Newton meter in 1 second. That is 1 watt. So, okay, we have solved this numerical. Now we want to move ahead. Now, what is the next topic? Location of hydraulic jump. Now we want to discuss how hydraulic jump can be created in open channels and how we can find their locations, that where it will form, exactly at what location. There are 2 broad ways by which we can create hydraulic jump. Number 1, by providing a sluice gate in the open channel. And what is the second approach? By providing the change of bed slope from steep to mild. All right. So these are the 2 broad ways by which we can create hydraulic jump. Now we want to know the location. This sluice gate we can provide in a channel having the mild slope or in a channel having the steep bed slope. In both cases, we can provide a sluice gate. Now, in case of change of bed slope from steep to mild, we have now 3 possibilities of formation of hydraulic jump. The number 1 is it may form exactly on change of slope location, which is this one. This is the steep bed slope and this is the mild bed slope, and this is the change of bed slope location. So the hydraulic jump is exactly forming or starting from this point. So this is the case number 1. What is the case number 2? The hydraulic jump is forming on downstream of change of slope point. Means it will form on mild bed slope. And the third is on upstream of change of slope point. Means it will form of steep bed slope. Now first we want to discuss this one by providing a sluice gate. Now this is the topic is by providing a sluice gate on which bed slope. First we want to discuss for mild bed slope. Now this is the bed of a channel, and which is this bed? This is the mild bed slope. Mild bed slope means S0 is less than SC or the critical slope. Now a hydraulic jump can be created by providing and closing a sluice gate. Not only by providing, but we have also to close. So we have to close this sluice gate and will bring up to here. How much we should close? We should close sluice gate in such a way that this opening of the sluice gate YS should be less than the YC. Then here, at certain distance downstream, L distance downstream, the hydraulic jump can form. The same thing is mentioned here. A hydraulic jump on mild slope can be created by providing and closing. So we have to provide and also close it. A sluice gate, how much we should close it? Such that YS should be less than YC. So this distance should be less than this. Then hydraulic jump will form. From sluice gate to beginning of hydraulic jump. This is the sluice gate and this is the beginning of hydraulic jump. Which profile will form? M3 profile will form because this slope is mild and this is type 3 curve. Why it is type 3? Because this water surface profile is formed below both of the lines. Which both of the lines? Normal depth line and critical depth line. So that's why it is the M3 profile. And how we can determine this L? This L we can compute easily by using this step equation. And how we have to analyze this hydraulic jump? So first of all, we will assume that this Y2, this is equal to Y0, which is the normal depth of flow. And using this equation of hydraulic jump, we will compute Y1. So if we know the Y1, we know the Y2, and if we have computed the capital L, and if we have computed the length of the jump, and we have computed the height of the jump, it means we have analyzed the hydraulic jump. So where it will form, everything, all dimensions we are giving. This means analysis of hydraulic jump. So do you have any question in this? By providing a sluice gate on the mild bed slope. If you have any question, you are welcome. Yes. No question?
No, sir.
Okay. How much should be the length of the jump? We have an approximate equation to compute this length of jump means from here to here because the jump is ending here. So this is the length of the jump and this is usually 4 to 6 times of Y2, the conjugate depth after the jump. Okay, now we will move to the next. Now what is the next case? Next case is that if we have a steep bed slope like this, in which the bed slope is more than the critical slope, then which type of flow will occur here? Supercritical flow. Now the hydraulic jump can be used to create the sluice gate can be used to create the hydraulic jump. But how much we should close the sluice gate? So this is the ys, and this opening of the sluice gate should be less than y0. If this would be less than y0, then on the upstream side there would be a hydraulic jump formation, and this water surface profile would be S1 water surface profile, and we can compute this length L by using the step equation. And here the water surface profile would be S3. Why it would be S3? Because it is lying in the zone number 3, which is below the both of the lines, critical depth line and normal depth line. All right.
Yes, sir.
So this is how a hydraulic jump can be created on a steep slope by providing and closing a sluice gate. So what should be the opening of the sluice gate? Less than the
Y0.
y0. Okay, now shall we go to the next? Now the second is way to create a hydraulic jump is to change the bed slope from steep to mild. Like we have, this is the steep bed slope, this is the mild bed slope, and we are discussing here 3 cases. So what is the first case? The first case, what is happening? A hydraulic jump is forming and starting at the change of slope point, means here. So this is the change of slope point. So hydraulic jump is starting from here, and maybe this is the y2 and this is the y1. What is in the second case? Hydraulic jump is not forming at the change of slope location, but it is starting at downstream of the change of slope location, means here, and here a hydraulic jump is forming on mild slope. And what is the third case? Third case is that a hydraulic jump may form on the upstream of change of slope location. So that 3 conditions are given here. Okay. Now how we can analysis of hydraulic jump to determine the location of hydraulic jump. I mean where it is forming, we take y2 is equal to y02. So initially we have to assume that this y2, which is the conjugate depth after the jump, this is equal to y02, and compute y1. What is y02? Y02 is the depth of flow in subcritical flow. What is y01? Normal depth of flow in supercritical flow, because here the flow is supercritical. So what you have to do is you have to assume that y2 is equal to y02, and by using this equation of hydraulic jump, compute y1, because q we know. So now once you have computed the y1, so based on the value of the y1, there could be 3 cases: case 1, case 2, case 3. What is the case number 1? Case number 1 is that your computed value of y1 is coming exactly same as y01, which is the depth of flow in supercritical flow. So it means in that case, hydraulic jump will form at the change of slope location, or it will start at the change of slope location. This is the simplest case and rare case. This is very rare. This is not very frequently observed case. Now, what is the second case? If y1, which we have computed from this equation, is greater than y01, then hydraulic jump will form on mild slope, that is downstream of change of slope section at a distance L. So here, so if this y1 is more than this value, it means definitely the hydraulic jump is forming on some distance, and that distance is L. And how we can find that distance L? That we can find with the help of a step equation. And we know the y2 and y1 And so this is the hydraulic jump, but this one is the M3 profile. What is the third case? If computed y1 is less than y01, so we assume that this y2 is equal to y02, and you computed y1, and y1 you are getting less than y01. So do you think, is it possible? You know, it is practically not possible. This is not possible that y1 should goes lesser than the y01. Then what we have to do? Now we have to reverse our assumption. Instead of assuming y02, now we will assuming y1, this is equal to y01. And then we will compute y2 from the equation of hydraulic jump, from this equation. And when you will compute y2, you will find that this y2 value would be less than the y02, which is this one. Okay, so that shows that the hydraulic jump will form on upstream of change of slope location. So this is the location of hydraulic jump. So you know y1, you know y2. Now you need to compute L, because you know this depth of flow y2 and you also know this depth of flow y02. So once you know these two depths, you can compute this capital L by using step equation. So this is how you can analyze a hydraulic jump on the change of bed slope from steep to mild. So do you have any questions?
सर इज इट पॉसिबल के हाइड्रोलिक जंप की स्टार्टिंग जो है वो स्टीप स्लोप पे हो और एंडिंग बेड स्लोप पे हो?
Oh, that's very good question. Uh, it's what do you think? What do you think? Is it possible?
I think sir it's
No.
not possible.
It's not possible. The reason is here the bed slope is mild, and the depth of flow would be normal depth of flow y02, and that will come up to here. Okay, so we don't expect. Oh, okay,
Sir.
Yes. Yes.
Sir,
Please.
as we have seen that case number 3 is not practically possible, then why we are analyzing it?
No. What I said, I have not said that this hydraulic jump is not practically possible. We have not discussed like that. Yes, what we have said that once we assume that this y2 is equal to y02 and we have computed y1, what we are saying that this y1 cannot be less than y01. Okay, that is not practically possible.
Okay,
And that's
sir.
why we started a reverse process. Now instead of assuming y2 equal to y02, then we said, okay, now assume y1 is equal to y01 and compute y2 from the equation of hydraulic jump. You
Okay,
got
sir.
my point?
I got it. Thank you.
So this hydraulic jump is practically possible. But what we said that the depth of y1 less than y01 is not possible. Okay, and that's why we changed our procedure.
Okay, sir.
Right. Now we want to solve numericals. We want to whatever we have discussed the theory, we want to apply it. And let's see the problem number 4. This problem says that a very wide rectangular channel, very wide means R is equal to Y, with bed slope 0.0003. So S naught is 0.0003. If the bed slope is so less, so what do you think? This is a case of mild slope case or a steep slope case?
Mild.
Yeah, it is very less slope, mild slope. and Manning's n is 0.02. Carries a steady, so n value is this. Carries a steady flow of 50 cubics per foot. So small q value is this. Now he's saying that if a sluice gate is so adjusted to produce a depth of 1.5 feet in the channel. So what is 1.5 feet? It is the opening of the sluice gate. So sluice gate is so close that opening remained 1.5 feet. Determine whether a hydraulic jump will be formed downstream of the sluice gate. So we have to first determine. So means we have to determine formation of hydraulic jump or occurrence of hydraulic. If so, and if so, I mean if the hydraulic jump is forming, then find the distance from the gate to the jump. Then this is the case. This is the gate. Gate means sluice gate. This is the gate basically. And find the distance from the sluice gate up to which the hydraulic jump is forming. So we need to compute this capital L. Okay. So we have to find L. So now we have to solve this problem. And how we can solve this problem? First of all, we should address this part, formation of hydraulic jump. And how we can check that a hydraulic jump will form. Yes, can anybody help me? We should compute.
We have to check YC.
Yes.
And opening we know, we will compare and then we can tell.
That's great. So how we can compute YC? We know the equation of YC for rectangular channels. Q is K over G power 1 over 3. So now write computing YC for rectangular channels. So YC that is equal to Q square over small g, its power 1 over 3. So please compute this.
6.34.
No. What the value of the G you are taking? The Q is given in English system. So we must use the value of G in English system, which is not 9.81, which is 32.2. So use value of G 32.2.
Yes, it's 4.26.
Oh yes, this is 4.26 feet. All right. So YS is 1.5 feet. And YC is 4.26. Now what is your opinion, your judgment? Would hydraulic jump form?
Yes, sir.
Yes, sir, it will form on downstream.
Okay, now please write as YS is less than YC. Hence, hydraulic jump will form on downstream of sluice gate. Now what else we have to compute? We should compute Y1. And how we can compute Y1? By using equation of hydraulic jump, this equation. And by assuming that this Y2 is equal to Y0. Okay. And do we have Y0, which is the normal depth of flow?
Yes, sir.
In the channel, we do not have.
No, sir, we
We
don't.
can calculate the hydraulic radius and then it will be equal to Y0.
So it means first we should compute. Now what should we compute? We should compute normal depth of flow. And how we can compute normal depth of flow? By using equation of small q. What is the equation of small q? V into Y. And what is equal to V from Manning's equation, because the Manning's n is given? 1.49 over n. And Y raised to power 2/3. Here y will become y naught. Y naught power 2/3 and into s naught power 1/2 into y naught. So then what is the equation, final equation of small q? 1.49 over n. Why 1.49 over n? Because we are using which system? English system.
Yes, system.
So the Manning's equation is not 1 over n, it is 1.49 over n. So y naught power 5 over 3 and s naught power 1/2. Now in this equation we know everything except y naught. Now please compute y naught. How much you are getting y naught? Hmm. Yes. What is the value of y naught? You are taking too much time.
Excuse me, sir.
Yes.
It's 8.97.
Yeah, it's good. 8.97 feet. So y
Yes,
naught is 8.999 I have. So 8.99 feet. So now I know the y naught. So now what should be the next step? I should assume y2 how much? Equal to?
equal to y naught.
8.9.
Yes. And using this equation of hydraulic jump, I should compute y1.
y1.
Yes. Now write, assuming y2 is equal to y naught is equal to 8.99 feet, comma, computing value of y1 using equation of hydraulic jump. Now write this equation. And put values. And then you have to compute y1. So when you will put values in this equation, so you will first get a quadratic equation. What's that? y1 square plus 8.99 y1 minus 17.27, that is equal to 0. Now you will solve this quadratic equation and the value of y1 you will get 1.62 feet. Are you getting the same? Please confirm. Have you solved it?
Yes, sir.
Okay.
1.62.
1.62. So y1 is 1.62. So we know now this conjugate depth, we know this conjugate depth. Huh? We also note the opening of the sluice gate. Now, can't we easily find this capital L distance by using this step equation? So now write computing length of M3 profile using step equation. And you know, for a step equation, first of all, you will write that ys on this side, ys is equal to how much? 1.5 feet. And then compute vs, that is the q over ys. How much you are getting vs? 33.33.
Yes, sir.
And then compute es, specific energy, which is the yx plus vs square over 2g. How much it would be?
84.9.
18.75 feet. And then next compute vm, mean velocity. Sorry, not yet, but first now come to one side. Huh? Now write y1. What is the value of y1 you got? 1.62. Then compute v1, which is the q over y1. It is 30.86 per second. Then compute E1, specific energy here. This is the 16.41. Now draw a horizontal line and compute mean velocity Vm. This is 32.09. And now compute Rm, which is the mean hydraulic radius. Yes. So you have also to compute R area 1 and wetted perimeter 1 and R1 on this side and also on that side. Area 1, wetted perimeter 1 and hydraulic radius 1. Then you have to compute the Rm, and the value of mean radius, hydraulic radius, is 1.56 meter. Now what we have to do? Now we should use Manning's equation to compute slope of energy line. Okay. And what is the Manning's equation? Here don't make ratta that the value of n is equal to this, because now we are using system English. So now write equation of Manning's equation Vm, that is equal to 1.49 over n, and r raised to 2/3 and s naught raised to power 1/2. So r would be r mean, v would be v mean, and put values in this equation. We know everything except s. Don't put not on subscript s on subscript not. Don't put subscript not. Huh? This is s, slope of energy line.
सर RM की वैल्यू थोड़ा बता देंगे?
किसकी जी? RM 1.56.
ओके सर.
So now compute slope.
Sir.
जी भाई.
Sir.
Yes.
सर ये जो मैनिंग्स फार्मूला हम लोग यूज़ कर रहे हैं,
Yes.
इसमें हम लोग डायरेक्ट जो डेप्थ ऑफ फ्लो गिवन है वो क्यों नहीं यूज़ करें? क्योंकि ये तो वाइड रेक्टेंगुलर चैनल है और इसमें हाइड्रोलिक रेडियस की जगह हम लोग जो डेप्थ ऑफ फ्लो गिवन है वो क्यों नहीं यूज़ कर रहे हैं?
It is not. क्या कह रहे हैं आप?
सर मैंने कहा कि ये वाइड रेक्टेंगुलर चैनल नहीं है?
Yeah, this is given कि wide rectangular channel है, and you can use direct Y भी कर सकते हैं, but as you know, we have computed now, we know the width and we know the depth of flow, so we can exactly compute the hydraulic radius. So if we do not have this information, then we can say, we can assume, okay, this is the wide rectangular channel, and we can use R is equal to Y. Could you got my point?
Yes sir, yes sir.
Okay.
Thank you sir.
If you will even use this, there is an approximate solution, and that is correct, no problem.
Sir, I have a question.
Yes.
सर जो हमारे बाथरूम में सिंक्स वगैरह होते हैं सर, उनकी जो सरफेस है सर वो भी स्लोप होती है
क्या? हाँ जी।
ठीक है सर। सर अगर हम उसको जो सिंक है सर, अगर हम उसको बंद कर दें और सर वहाँ पे पानी अकोमोडेट करना शुरू कर दें, तो सर अगर हम पानी स्पीड से सर अगर रिलीज करें तो फिर सर वहाँ पे भी हाइड्रोलिक जंप फॉर्म होती है कि नहीं? क्योंकि सर वहाँ पे भी ना पानी अचानक से इकट्ठा होना शुरू होता है और उसकी भी प्रोफाइल हाइड्रोलिक जो जंप की तरह बनती है।
ओके, इफ यू कैन प्रूव कि सुपर क्रिटिकल फ्लो इज चेंजिंग इनटू सब क्रिटिकल फ्लो, then you can prove that hydraulic jump is forming. And if supercritical flow is not changing into subcritical flow, we cannot say that hydraulic jump is forming. और उसमें ऐसा नहीं, पहले डेप्थ ऑफ फ्लो ज्यादा है फिर कम हो रही है, ठीक है?
ठीक।
चलो।
And sir in this we are analyzing that the flow is moving from up to down, मतलब ऊपर से नीचे जा रहा है फ्लो। सर अगर हम बैक पे चले, मतलब नीचे से फ्लो ऊपर लेकर जाए, तब सर हाइड्रोलिक जंप फॉर्म हो सकती है कि नहीं?
Actually, then there is flow, one flow is in the pipe. जो बैक फ्लो आप करेंगे ना, that would be pipe flow, वो ओपन चैनल फ्लो नहीं है. And in pipe flow there is no concept of subcritical and supercritical flow. जो आपके उसमें टप में फ्लो होगा वो कौन सा होगा? वो ओपन चैनल होगा, तो वो कंपेरेबल नहीं है दोनों. So we cannot say anything. अच्छा जी, S निकल गया. How much is the slope of energy line? It is 0.103. Yes, very good.
Yes.
This is slope of energy line. Now we know the step equation. This is the step equation. So this should be ES and this should be E1. S minus S naught. S naught is given. Now compute capital L.
22.9.
22.9 feet. Very good. So this is the length of M3 profile, or this is the length of gradually varied flow. From here to here flow is gradually varied flow, and from here to here flow is which flow? Rapidly varied flow or hydraulic jump. So with this we have solved this problem. So any question you have, you are welcome. Do you have any question?
No sir.
And now shall I stop the recording and also